Let's talk about the preparation of oxygen. The best way of doing so is via the fractional distillation of atmospheric air. There is no better way of obtaining pure oxygen, but it cannot exactly be done in the lab. However, what we can do in the lab is the electrolysis of water, in which we can obtain not only oxygen, but we can also obtain hydrogen as well. Well, some other ways we can do it in the lab is by taking a metal permanganate. The metal permanganate, we thermally decompose it, and the thermal decomposition of a metal permanganate will produce the respective metal manganate, manganese dioxide, a black color solid, and oxygen will also be evolved. Or we can take a metal chlorate and thermally decompose it, then in which we and after that we will be able to obtain the metal chloride and pure oxygen. Another but a more difficult means of getting it is by taking the oxide of a precious element like silver oxide, platinum oxide, mercury oxide, and then if we were to thermally decompose it, we will be able to obtain oxygen. And then we have peroxides and superoxides of S blocks ideally, and we thermally decompose it. The thermal decomposition of a metal peroxide will yield the metal hydroxide and oxygen gas, while the thermal decomposition of a metal superoxide will yield the oxide, the metal oxide, and oxygen. Another means of getting oxygen is by thermally decomposing group 1 metal nitrates like sodium nitrate, potassium nitrate. It will thermally decompose to form the respective nitrite. The group 1 metal nitrate will decompose into the group 1 metal nitrite and evolve oxygen. Another atypical means of obtaining oxygen, I know not ideal, not a good way, it's just a reaction which produces oxygen as a product, byproduct even. Here, if we were to react fluorine gas with cold water, we will obtain hydrogen fluoride or hydrofluoric acid and diatomic oxygen. Not a good way of obtaining oxygen, however. And here's the very atypical reactions of getting oxygen. If we were to take PbO2 and thermally decompose it, we will be able to obtain PbO, and oxygen will be evolved also. If you were to take CrO3, chromic 3 oxide, and thermally decompose it, you will get chromic Cr2O3. Both of these are oxides of chromium. Here it's in the +6 oxidation state. Sorry, this is chromium 6 oxide, and this is chromium 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 this is chromium 3 oxide. Yeah, this is chromium 3 oxide. This is chromium 6 oxide. This is chromium 3 oxide. It will turn from red to green color and will evolve oxygen as a byproduct. And these are the means of obtaining oxygen.